Unit 8 Starstruck. It's hard to be modest when you live in the Milky Way. Our galaxy is brighter and more massive than most other galaxies. From end to end, the disk-shaped Milky Way spans 120,000 light years. Encircling it is another disk composed mostly of hydrogen gas, and enclosing that is an enormous halo of dark matter. Indeed, our galaxy is so huge that dozens of lesser galaxies cycle it like moons orbiting a planet. Giant galaxies like the Milky Way and the nearby, even larger Andromeda galaxy possess the power to create a rich supply of iron, oxygen, and other heavy elements heavier than hydrogen and helium. Such heavy elements are the building blocks of planets and are essential for life. When a star explodes into a smaller galaxy, this raw material shoots out into space and is lost. But in the vast Milky Way, the elements of encounter gas and dust along their path and are restrained by the strength of galaxies' gravitational field. These impediments slow their speed, so they can enrich star-forming gas clouds with the ingredients for new generation of stars and planets. That's what happened 4.6 billion years ago when the sun and the earth were born. Because we reside within the Milky Way, we actually know less about its overall appearance than we do about distant galaxies. Think about it in this way. In the absence of a mirror, you know more about your friends' faces than your own. Nevertheless, in the past decade, astronomers have made numerous startling discoveries about our galaxy, beginning with the revelation that a huge black hole lies at its heart. Every star in the Milky Way revolves around this black hole, named Sagittarius, the A star. The Sun, 27,000 light years away, completes a revolution once every 2,030 million years. Within this light year of black hole, there are more than 100,000 other stars caught far more firmly in its grip. Some take only a few years to complete their orbits. These parts reveal that Sagittarius A star is 4 million times the mass of the Sun. Every now and then, the black hole swallows a planet or star like a particularly voracious vacuum cleaner. The victim is heated to such high temperatures that it lets out an explosion of X-rays which light up nearby gas clouds. This helps keep a record of the black hole's past visits. For example, in 2004, scientists reported an X-ray echo in a gas cloud some 350 light years from the black hole. Since X-rays travel at the speed of light, the echo indicates that an object fell into the black hole around 350 years ago. The X-ray intensity suggests that it had the mass of a small planet. Surprisingly, the black holes also fling stars away. In 2005, astronomers reported a star racing away from the galactic center. At 709 kilometers per second, at that speed, it would soon leave the galaxy. 15 more of these fast-moving stars have since been discovered. Over the Milky Way's lifetime, the black hole may have flung 1 million stars out of the galaxy. Despite the violence around the black hole, the galactic core is a fertile place. Stars congregate at the galaxy's center, so the life-giving heavy elements they create are more plentiful there. Even the newborn stars near our Sun, halfway between the black hole and the edge of the galaxy, possess orbiting disks of gas and dust that survive long enough to give birth to planets. In contrast, prospects for planets at the galaxy edge are bleak. Over 100 newborn stars at the edge of Milky Way were recently found to have low supplies of heavy elements. For example, their oxygen content was only 20% of the Sun's. Most of these young stars have already lost their planet-forming disks of gas and dust. No disk, no planets. No planets, no life. Stars with even lower amounts of oxygen and iron offer insight into the birth of the galaxy itself. Residing in the halo, extending above and below the galaxy's disk, these stars are so ancient that they formed before earlier generations of stars had a chance to produce heavy elements. Astronomers date these stars and hence the age of entire galaxy by studying globular cluster, tightly packed grouping of other stars. However, estimates of this age depend on theories of how stars live and die. Fortunately, there is another way to measure the star's age. In 2005, a German graduate student named Anna Friedberg began looking for individual stars in the halo. She discovered one that was chemically primitive. It had relatively few elements, meaning it must have been born before many generations of stars had chemically enriched our galaxy. And this halo star contains elements that are far heavier than iron, including uranium. She measured the amount of uranium using a method similar to carbon dating and estimated the star's age at around 13.2 billion years old. That figure suggests that Milky Way is only slightly younger than the universe itself, which is 13.7 billion years ago. The mighty galaxy, whose countless stars would later make life possible on Earth, certainly didn't waste any time being born. Thanks for listening.